This section we're going to talk about compound interest. So first of all, what is compound interest? Suppose at the end of each payment period, the interest that you earn is reinvested at the same rate. Then the interest previously earned, as well as your principal that was invested, will earn interest. When interest is paid on previously earned interest, this is referred to as compounding. And you'll find that this compounding concept can be very powerful with investments, especially if it's over long periods of time. Now, the interest earned is actually called compound interest. And so we're going to begin with an example from simple interest and see how we can develop this compounding. So let's start with this example. Suppose you invest $2,000 that earns an annual interest rate, or an APR, of 4%. Now assume money is compounded each quarter of a year, in other words, every 3 months for a period of 2 years. We would like to know the amount or future value of this investment at the end of 2 years. Now, this solution is simply an example that shows you how the compound interest formula can be developed from the simple interest formula. We will not actually solve future problems like this. Okay, let's get some specifics. First of all, we know that we will invest a principal of $2,000. We know the annual interest rate is 0.04 in decimal, but that is only if there is no compounding. So that would only be under simple interest. We actually will need the rate earned per quarter. So, because we have quarterly compounding, so we're going to need to figure out the rate per quarter. Well, that's easy to do. Just divide the rate by 4. So the rate earned per quarter would be the 4%, 0.04, divided by 4, or 0.01. So we would earn 1% per quarter. We also need to know how long we will invest the money. Now, we were given 2 years, but let's see how many quarters that becomes. Since we have 4 quarters in each year, then we have a total of 8 quarters. And each quarter is 1/4 of a year. Now, here's a major point. We're going to assume there's no compounding between quarters. That means that we can find the balance from quarter to quarter by using the simple interest formula. So we can use this formula right here that we use for simple interest to find the balance as we go from quarter to quarter. And we know that our initial principal is $2,000. We know the rate is 0.04, and we know that each quarter is 0.25 years. So we know that each time we go from quarter to quarter, the time will be 0.25 years. Now, so at the end of quarter 1, we would have 2,000 times 1 plus 0.04 times 0.25, that's for 1/4 of a year, which would equal $2,020. Well, then, if we let the money stay, let it ride, so to speak, if we just let it ride and leave it in there for another quarter, then for the next quarter we would start with $2,020 and we would multiply that by 1 plus 0.04 times 0.25. That turns out to be $2,040.20. And then if we leave that in there for the next quarter, your principal would be $2,040.20, and we would multiply it by the 1 plus RT, which is the same all the way through here. 1 plus RT is always going to be 1 plus 0.04 times 0.25. So that's 2,060.60. And then if you multiply that by the 1 plus RT, you get 2,081.02. So at the end of the first year, I've got 2,081.02. Now, at the end of quarter 5, for the next year, 2,081.02, multiply that by 1 plus 0.04 times 0.25, we get 2102.02. And then quarter 6, take 2102.02 and multiply that by this expression, and you get 2123.04. And then at the end of quarter 7, similarly, at the end of quarter 8, similarly, and so forth. Now, it looks like I left off a parentheses on each of these. There should be an extra parentheses on each one of these to the far right, so that's my bad. But anyway, at the end of the second year, you get 2165.71. Now down here I'm showing you how much your money earns, how much your money grows to each quarter, at the end of each quarter. So at the end of each quarter it tells you what the money grows to, and you can see that by the end of the 8th quarter you've earned a total of $165.71. But what I want you to look at is this. Look at the difference in the interest earned. So the first period you earned $20 in interest. But the next period you earned the $20 plus another $20, but you also earned 20 cents. Well, that 20 cents was what you earned on that interest of $20. Now on the next period you earned $20 and $20 and $20, which is, and then your 20 cents, but notice that there's 40 cents more here. Well, it gets a little complicated if I keep trying to go back, but basically the 40 cents that you earned is the interest you earned off of the interest from the previous 2 periods, and so forth. So therefore your interest is compounding. So with compound interest, that's what's happening. Now, to get to a formula, let me just kind of recap what we did here. If you think about it, each time in each one of these formulas, I multiplied the previous principal by this calculation, 1 plus 0.04 times 0.25, which is actually just 1.01, 1 plus 0.01. So actually, let's think about, to get the first period, I took 2,000 and multiplied it by 1.01. And then to get the amount at the end of the second period, I took what I had from up here, the A1, and then I multiplied it by 1.01. So in other words, A1, remember A1 was equal to this, right? So what I had to do was I had to multiply this by 1.01. Well, if you look at that, that's really just 2,000, the initial principal, times 1.01 squared. Well, to get A3, I had to take A2 and multiply it by 1.01. Well, A2 is 2,000 times 1.01 squared, and if you multiply that by 1.01, you get 2,000 times 1.01 cubed. Now, if you continue this process, you'll see that the final amount that I wanted, the amount at the end of the 8th period, that's simply equal to 2,000 times 1.01 to the 8th power. So actually there's a formula developing here, and if you tried that, if you actually put in this formula 2,000 times 1.01 to the 8th power, you actually do get the 2165.71 that I got up there in the answer when I did it the long way. So this actually develops a formula. So if you take a look at, let's take a look at what gets developed here. So we know n will represent the total number of compounding periods. So we'll let n, and we let n equal 8. By multiplying the number of compounding periods per year, 4, by the number of years, 2, that's how we got the 8. We'll come back to that. Next, we need to know, where did we get the 0.01? Well, actually, all I did to get the 0.01 was I took the annual rate, 0.04, and divided it by 4. Now, I'm saying you multiply it by 1/4, but that's actually just dividing it by 4. So you just take the 0.04 and divide by 4. And so we'll call that 4 the number of compounding periods per year. Since we're compounding quarterly, we know that we have 4 compounding periods per year. So, and like I said, if you multiply 0.04 by 1/4, it's the same as dividing by 4. So therefore, 0.01 is simply the rate, which is 4%, 0.04, divided by the number of compoundings per year, which is 4. So that gives me 0.04 over 4, which is 0.01. Now let's return to n. Now remember, I said n was determined by the number of compounding periods per year, m, multiplied by the number of years. So n is m times t. So if we think about it that way, go back to this formula that I had. Remember, I told you up here that I got the answer by just taking 2,000 times 1 plus 0.01 to the 8th. Well, the 2,000 is just the principal, so I'm just using the principal there. and then I'm multiplying that by 1 plus, remember the 0.01 is just the rate divided by m, so I just took the annual rate divided by m, the number of compounding periods per year, and then the exponent here, 8, that was just m times t, where m is the number of compounding periods per year and t is the number of years. Okay, so this looks a little confusing now, but actually the formula is that A is equal to the principal times 1 plus I, where I is your interest rate per period, and I is calculated by taking the annual interest rate and dividing it by the number of compounding periods per year. So if you're compounding quarterly, you would take R and divide it by 4 to get this I. If you compound monthly, you would take R and divide it by 12 to get this I, and so forth. And then N is your total number of compounding periods, and the way you get N is you take the number of compounding periods per year and multiply by the number of years. So if you're compounding 4 times a year, you would just take 4 times the number of years. If you're compounding 12 times a year, you would take 12 times the number of years to get N, and so forth. All right, so I'm going to wrap this video up with finishing up with the formula. So the formula for finding the amount when you have compound interest is that the amount, or the future value, is the principal times 1 plus R over M raised to the N. Now you can actually just call this I. R over M and I are the same thing. So it's the principal times 1 plus R over M raised to the N, where A is the amount or future value, P is your principal or present value, R is your annual percentage rate, again in decimal, M is the number of compounding periods per year, I is actually your interest rate per compounding period. That's what you get when you divide R by M, is the interest rate per compounding period, and T is the number of years. And then N is the total number of compounding periods. So if you're compounding, say, 30 years and you're compounding quarterly, N would simply be 4 times 30, which is 120. So anyway, if you didn't fully understand the development of this formula, don't worry about it, because in the next video where I work these problems, I'm not actually going to, we're done with that type of stuff, and we're just going to work with this formula here from here on out in this section.